Okay, shall we start? Hi, today we are going to start my new lesson with a mechanics lesson. Okay, so you have to maintain a separate book for this part today. In mechanics, today is our first day of mechanics. Mechanics, this is the longest unit in physics. Actually, we will do this unit about 3 terms. Actually, we have to do 3 terms. This unit is very long unit, and that this is the uh, most important unit in physics mechanics, because lot of questions are based on mechanics. Normally, if you consider about the structure of paper, you know there are 3 kind of papers. The first one is MCQ, is structure, and essay. In mechanics, there are about 12, 11 or 12, sometimes 13 MCQ question in MCQ paper. If we consider about that my value is the average is 12, there are about 12 MCQ questions. 12 MCQ question means you will have 12 marks in your final paper. 12 marks in final paper. Because 1 mark in MCQ paper, 1 mark is equal to 1 mark in the final paper. And this is an approximate figure. But normally it will be around 11 to 13. Okay. Structure. In structured question paper, there are 4 questions. Basically, the first question is based on the first practical list. Therefore, there is a very huge possibility to have a practical based on mechanics. Normally, it will be based on mechanics. Therefore, there is about 90% of possibility to have a question in mechanics in MC structured essay paper. So, if there is a mechanics question, it will be 20 marks in structured paper. 20 marks in structured paper. That means 5 marks in final paper. 5 marks in final paper. Then, the first question in the essay paper is based on mechanics. The first question in essay paper is based on mechanics. Therefore, it is about 30 marks. Therefore, 7.5 marks in the final paper is based on mechanics. Therefore, altogether how much? 24 something, no? 24.5. And so this is a very huge mark. This is very huge mark. Therefore, if we consider a single unit, so this is the highest mark based on single unit. Therefore, this is the most important lesson in your physics syllabus, mechanics. So, if we can do this lesson very smart way, then definitely you can get approximate this much of mark in your final paper. Therefore, this is very useful. Okay, so as I mentioned you earlier, this is the first day of mechanics. So in mechanics, if you consider about the unit mechanics unit, We can divide this unit into several segments. First one is static. Statics. Static means that is the physics, or that is the science behind stationary object. So we will study about stationary object in a static lesson. Then the second segment is dynamics. Then we can categorize the next step is rotation, sorry, angular motion. Then fluid mechanics. Those are the main parts. Those are the main subcategories in mechanics. Yeah. So under statics, we will learn vector. Vectors. We will learn about vectors under static part. Then equilibrium of forces. Then third, center of gravity. Then under dynamics, we will learn linear motion, then projectiles, Newton's laws, work and energy. There are several subcategories in these topics today. In Newton's laws, we will have to study about linear momentum conservation, then frictions, frictional forces. Therefore, there are several subcategories under this unit, but basically those are the major units in dynamics. Then, angular motion can be divided into two major categories. One is rotational motion. Secondly, circular motion. Fluid mechanics also, it can be divided into two major categories. One is fluid static. Second one, fluid dynamics. So those are the major units in mechanics. And so those units are very, very important unit in your syllabus, as well as those are relatively large Therefore, we have to spend at least 3 terms to complete this one. Okay. So take a new book, write topic mechanics. Then you can write the paper structure here. This is the structure of paper. This is the unit content. Okay. Tanggal Okay. I finished. Okay. Have I finished with it? Once you finish typing, please give me a thumb. Okay, thank you. Then, in mechanics program, you have to keep separate books for these four separate main subunits program. So you have to maintain a book for static, book for dynamic, book for angular motion, and fluid mechanics separately. Okay. Therefore, today you have to write vectors in your static book. Static book. Okay. Hi. Shall we start? Hi. Today, in vector, if you consider about vector lesson, there is some portion of vector lesson in unit number 1 as well as unit number 2. Therefore, we will study all of them together in mechanics. Okay. Hi. Right topic vectors. Vector. First subtopic is definition. Okay, now tell me, what is a vector quantity? What is a vector quantity? Actually, we have discussed a little about vector quantity in my unit and dimensions. So tell me, what is a vector quantity? What is a vector quantity? What is the vector quantity actually? Hmm? Darshan? Yes. What is a vector quantity?
Direction of the scale.
Yes. Hmm. Vector quantity means suppose if any physical quantity has both magnitude and direction, such kind of quantities are called vector quantities. Therefore, for vector quantities, there is a very special feature. What is that? It has a magnitude as well as a direction put there. So that is the common feature for every vector quantity. Actually, we will learn there are several subcategories, several classifications regarding vectors put there. So, if we consider about any kind of vectors, if we consider any kind of vector, there are two common features. There are two common features. What are those? All of them have a magnitude and a direction. A magnitude and a direction. Therefore, if any physical quantity has a magnitude as well as a direction, we call them as vectors, vector quantities. Okay, they're right there. Definition. A physical quantity that has both magnitude and direction. That has both magnitude and direction. A physical quantity that has both magnitude and direction is called a vector quantity. Is called a vector quantity. Second one. Classification of vector quantities. Second topic is classification of vectors. There are several classifications for there. So here I'm going to consider about the basic properties of vector quantities. Because there are some basic properties of vector quantities. So based on the basic properties, we can divide vector quantities into three major categories. Three major categories. First one. Actually, if we consider about a vector quantity, okay, as you know in your orders, you know about force, displacement, then what else? What else? How are the vector quantity are? Orders color correct? Force, displacement, accelerations, those are vector quantities. Those are vector quantities. They have both magnitude as well as direction. But if we consider about scalars means a physical quantity that has a magnitude only. They don't have a direction. If you consider about time doesn't have a direction. No, Pute, time it is just a magnitude. Pute. Time has no direction. Time. Then mass has no direction. Therefore, such quantities means physical quantities having magnitudes only are called scalars. Scalar quantity. But in vectors, they have both magnitude and direction, such as force, displacement, then velocity, acceleration. Those are vector quantities. They have both magnitude and direction. So not only magnitude and direction, some vector quantities have line of action and point of action. Line of action and point of action. Based on that two characteristic features, we can categorize vectors into three major categories. Put some vectors have magnitude and direction only. Some vectors have magnitude and direction only, but they don't have a line of action, a specific line of action or a specific point of action. You know, you have actually you have discussed about displacement and velocities in your oral syllabus. No, you know displacement. So if it is a displacement, actually we can mention the displacement using a magnitude and a direction. No, it doesn't have a specific point of action or a specific line of action. Sometimes, suppose now this is a straight line. So there is a point A and point B here. So if any object goes from A to B, the displacement is from here to here. We can say from here to here 100 meters. And we can also mention it from here to here 100 meters. Both are correct. Okay? We can mention the displacement from here to here 100 meters, from here to here 100 meters, from here to here 100 meters. So we can mention this vector from here to here. So we can mention this vector in any case. That means there is no specific line of action or point of action for displacement. It has only a magnitude as well as a direction only. It has only a magnitude and a direction only. Therefore, such kind of vector can be represented by a magnitude and the direction in anywhere in the space. That means if the magnitude and the direction is same, if the magnitude and the direction is same, if the magnitude and the direction are same, we can represent this vector in any way. Therefore, there is no any specific point of action or line of action for displacement. Therefore, there are some vectors. Those vectors have magnitude and direction only. Magnitude and direction only. Such kind of vectors are called free vectors. Free vectors. Free vectors. Free vectors. Free vectors means we are free to represent that vector if the displacement and the magnitude are correct. If they are correct, we can represent this vector anywhere in the space. Anywhere in the space. අපිට මේ ස්පේස් එක ඕන තරම් මේගොල්ලෝ මාක් කරන්න පුළුවන්. අපි එකම කන්සිඩරේෂන් එක මැග්නිටියුඩ් එකයි ඩිරෙක්ෂන් එකයි වෙනසක් නොවි තියෙනවා. මේ දෙක ඕකේ නම් මෙයා මෙතනින් මාක් කරත් මෙතනින් මාක් කරත් ප්‍රශ්නයක් නැහැ. So these are called free vectors. Free vectors. Example for free vectors. අපිට ගන්න පුළුවන් examples. What are the examples? Displacement. Then velocity. Velocity also free vector. Then acceleration. Those are free vectors. Those are free vectors. Though these vectors have magnitude and direction only. Magnitude and direction only. But there's some vectors have magnitude, direction, and line of action. They have 3 features. Some vectors have 3 features. What are those 3 features? magnitude and direction are two mandatory features. If it is a vector, definitely they should have a magnitude and direction. Therefore, these two are mandatory features. So, other than these two features, some vectors have a line of action. Line of action only. They have these three features only. They don't have a point of action, but they have a line of action. They have a line of action. And so those vectors are called sliding vectors, but the sliding vectors. And the most common sliding vector is force. Force on a rigid body. Force on a rigid body. That means suppose now this is a rigid body. Now we can apply a force, 10 Newton force on this object. 10 Newton force on this object. I'll make a name for them. Okay, look at this one. We're going to move well, now look at this one. Now there's a box. There's a box. So if I apply a 10 Newton force, the same force from here, from apply. Now, if I apply a force from here, actually there is no motion. But if I apply a force from here, what will happen? This can fall. This can fall. This can fall. Similar thing. If we apply a force, to open a door, if we apply a force, now this is a door. Okay. So if we apply a force from here, it is very hard to open. No, it is very hard to open. But if you apply a force, if you apply the same force from here, then what will happen? It is very easy to rotate. It is very easy to rotate. No? As I mentioned you earlier, if we apply a force from here, it is hard to roll this object. But if I apply a force from here, what will happen? Now it is easy to roll this object. It is easy to roll this object with it. Yeah, that means definitely according to the line of action, the final result of the force vary good. Therefore, line of action to line of action, their result can be changed. Therefore, not like a displacement or velocity or acceleration. According to the line of action, the result, the final output of a force can be changed. Therefore, if the final result of a vector, if the final output of a vector change change according to the line of action, then they have a line of action feature. They have that feature. Therefore, such vectors have magnitude, direction as well as line of action, because according to the line of action, their final result can be changed. Did you get my point? If you got that done, please raise the hand. Therefore, these vectors are called sliding vectors. Actually, Bhute, if we consider about sliding vector, the sliding vector can apply at anywhere, at any point on the line of action. It can apply on any point on the line of action. The result is same. That means if you push an object with 10 Newton force, you will have a certain result. That the same result can be obtained using a pull-out force. On the same line of action. Line of action. Is a line of action. 10 Newton force apply. That is the that's why we call them as sliding vectors. So we can slide this vector. We can slide this vector along its line of action. We can slide these vectors along its line of action without changing the end result. Okay. Therefore, those kind of vectors are called sliding vectors. Then the final one. Magnitude. The final type of vectors have magnitude, direction, line of action, as well as point of action. They have all of them. So most point of action again. So these kind of vectors have magnitude, direction, line of action as well as point of action. They have all the features. But most important thing is all of them have two common mandatory features. What are those? Magnitude and direction. So if any vectors have all these four characteristic features, we call them as tied vectors. Tied vectors. That tied vectors means that we cannot move this vector anywhere because it has a specific point of action. It is exerted at a specific point. Therefore, we cannot change the position of those vectors. That is the reason we call them as tied vectors. They are tied. And therefore, we call them as tied vectors. Most common example is to the weight. Weight has a special point of action. Weight has a special picture. Weight has a special point of action. 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 Weight has a special point It has a special point of action. We call it as center of gravity. Center of gravity. We will learn it then that one. It is called as center of gravity. Therefore, a force is sorry, a weight. A weight is exerted at that point. The center of gravity of the object. The center of gravity. Therefore, it has a point of action, and weight is always in vertically downward direction. They are in vertical downward direction. Therefore, it has a specific line of action too. It has a specific line of action too, as well as direction and magnitude. Therefore, this is the point of action. We call it as center of gravity. This is the line of action. Line of action towards the earth. Therefore, if we consider about this type of vectors, they have magnitude, direction, line of action, and point of action. Therefore, when you are defining a vector quantity, you have defined it as a physical quantity which has a both magnitude and direction, because every vector quantity has two mandatory common features. What are those? Magnitude and direction. Therefore, don't say vector quantity, all the vector quantities has line of action and magnitude, point of action. Every vector quantities do not have those features. Those features are shown by some special type of vector quantities only. And they are called sliding vectors and time vectors. Sliding vectors and time vectors. Did you get my point? පැහැදිලිද ඒක? තේරුණාද? මේ නිසා සමහරලාට වැරදියට define කරනවා මොකද්ද vector quantity එක කිව්වා line of action, point of action, magnitude, direction ඔක්කොම කියන සමහරලාට. ඒක වැරදි. එහෙම දෙයක් නෙමෙයි. vector quantity එක කිව්වහම vector quantity එකක් වෙන්න තියෙන්න ඕනි features දෙකයි. ඒ features දෙක fulfill වෙච්ච ගමන් එයා vector quantity. හැබැයි vector quantity මේක free vector එකක්ද sliding vector එකක්ද type vector එකක්ද කියලා කියන්න මේ features දෙක තියෙනවද නැද්ද කියලා බලන්න. ඒ වුණා vector quantity එකක් වෙන්න අවශ්‍ය two mandatory features දෙකක් විතරයි. Then you can write this classification. Tagal classification. Have finished? Have finished?
Yes, sir.
Okay. Then third one, differences between vector quantities and scale quantities. Differences between vector quantities and scale quantities. Alright. A vector scalars. Okay, you know, vector quantities has a direction. They have direction. Scalar have magnitude only, they don't have direction. That is first one. Then another difference with it. So if we know, if we consider about scalars, Puti, if we consider about scalars, we can do normal mathematical operation. That means such as addition, subtraction, multiplication, division. Those kind of things can be done for scalars in normal way. Normal way means we can consider them or we can treat them as a numbers because scalars do not have any magnitude. Therefore, we can multiply, add, divide, or subtract them without any special considerations. But if we consider vectors, Pute, we cannot treat them as normal numbers because they have a magnitude as well as a direction. Therefore, we cannot add, subtract, multiple, or divide vectors as my normal numbers. Therefore, there are several principles to addition, to subtraction, multiplication, vectors. Therefore, vectors cannot be subjected to normal mathematical operation as numbers. We have to learn those mathematical operations for it. But if you guys about scalars, they can treat actually we can treat them as normal numbers. Therefore, we can apply mathematical operation in normal way for scalars, but vectors we cannot. We cannot. There are some special considerations. Okay. Here, normal mathematical operations can be applied as numbers. As they have directions, we cannot apply mathematical operations in general as numbers. So those are the two main differences between scalars and vectors. But there are a lot of differences, but these two are the two main differences between scalars and vectors. Okay, right. Okay. There are next topic. Fourth one. Fourth topic. Representation of vectors. Representation of vectors. Representation of vectors. Representation of vector. But the representation of vector can be done in two ways, mainly two ways. One is geometrical representation. The second thing is algebraically representation. And actually, geometrical representation means if we can represent a vector using a line segment means it is a figure. Geometrical means actually it should be a figure. Geometrical representation means representation of something using a figure. Therefore, geometrical representation of vector means representation of vector as a figure. Algebraic representation means algebra means it is something like unknown quantities, so a b c or x y z, something like such kind of quantities, such kind of terms to put it. So algebraic representation means representation of vector using English letters. Has. You know, a vector means vector has two major properties. What are those? A magnitude as well as a direction. A magnitude as well as a direction. Therefore, if you represent a vector using either way, you have to represent both magnitude as well as direction. That is that should be the consideration. Because if you use a geometrical figure to represent a vector, that figure should contain the direction as well as the magnitude of the vector. If we use English letters, to represent a vector, that representation should have the magnitude as well as the direction of the vector. Therefore, both ways should represent the magnitude and the direction of the vectors. There are this one. Representation of vector. The first one. Then first subtopic is geometrical representation. Okay. There are this topic, geometrical representation. Other topic, start with this paragraph. Okay. If a vector is represented by by a geometrical figure, comma, it is called a geometrical representation. Hello there. Where are this one? This figure should represent both magnitude and direction of the vector. Both magnitude and the direction of the vector. Yeah. Correct. Hello there. Look at this. Look at the board. To represent a vector in a figure or using a figure or in a geometrical way, we will use a line segment. This line segment is drawn into the direction of vector. Therefore, we can use an arrowhead. Which is drawn towards the direction of the vector to represent the direction of the vector. So this line segment should be drawn into the direction of vector. That means this line segment and the direction of the vector should be parallel to each other. They should be parallel to each other. Although it is parallel, the vector can be in A to B direction or B to A direction. Therefore, to represent the exact direction, we have to mark an arrowhead. Therefore, from that, we can represent the direction of the vector. Therefore, the direction of the vector can be represented by the direction of the line segment as well as the arrowhead. This line segment, this AB line segment is parallel to the direction of the vector, and this arrowhead is shown the exact direction of the vector. Therefore, the direction of the line segment and the arrowhead are used to represent the direction of the vector. Yes. Then, how to represent the magnitude? How to represent the magnitude, Putin? The magnitude can be represented by the length of the line segment, by the length of the line segment. So in such case, we can use a scale, Putin. We can use a scale. The scale means, suppose we have to represent 100 Newton force from a line segment, Putin. Suppose we have to represent 100 Newton force. Then I can define a scale. I can define 10 Newton. 10 Newton is represented by 1 centimeter. 10 Newton is represented by 1 centimeter. Then, if I draw 10 centimeter long line segment, if I draw a 10 centimeter long line segment, definitely this line segment should be equal to 100 Newton force. Because 10 Newton is represented by 1 centimeter, therefore 100 Newton is represented by 10 centimeter. Therefore, you have to draw a 10 centimeter long line segment into the direction of 100 Newton force, and you can mark the arrowhead towards the exact direction of the vector. So this is the way of representation of vector in geometrical way. So as a summary, how to mark the or how to represent a vector in geometrical way. So you have to use a line segment which is drawn towards the direction of vector. Then the exact direction should be marked by a line arrowhead. Then the magnitude can be represented by the length of the line segment. The length of the line segment should be determined according to the predetermined scale. Predetermined scale. So you can predetermine the scale. According to this scale, we can determine the length of the line segment. Did you get my point? If you get my point, please raise the hand. Okay. Then draw this one. Please listen to me. Once we draw once we represent a vector in geometrical representation, so this point is called the starting point of the vector, because now vector is from here to here. Now look at the arrowhead. Now arrowhead is directed towards the B. Therefore, vector is from A to B. Vector is from A to B. Therefore, this is called the starting point of the vector. Because arrowhead starts from here and directed towards the B. Directed towards the B. Therefore, arrowhead is directed towards the B. So this is the end point of the vector. End point. End, or we call this end or termination point. Those are the 2 points. Those are the 2 points in a geometrical representation. Okay, mark it. I finish. Okay, then I can do this. Here we can use, here we can use a line segment which is drawn, which is drawn towards the direction of the vector, which is drawn towards the direction of the vector. Full stop. An arrowhead can be used. An arrowhead can be used an arrowhead can be used to represent the exact direction, to represent the exact direction of the vector, to represent the exact direction of the vector. An arrowhead can be used to. So what is the last sentence? Play? What is the last sentence?
An arrowhead can be used to represent the exact direction of the vector.
Vector, no? Okay. Write in another para. The length of the line segment, the length of the line segment is drawn into a scalar which is corresponding to the magnitude of the vector, which is corresponding to the magnitude of the vector.
which is corresponding to the magnitude of the vector.
Vector. Okay. The second topic is algebraic. Algebraic representation. But in algebraic representation, we will use some English letters to represent the vector. It is something like this AB. Here, this is the starting point of the vector. This is the starting point of the vector. Here the end point. And this is the exact direction put in. This arrow shows the exact direction of the vector. So normally this is the algebraic representation put in. So if you want to represent the magnitude, then we can equate this algebraic representation into some value. It is something like this. AB vector is equal to 10 Newton. AB vector is equal to 10 Newton. Then we can say AB vector shows a force which is equal to 10 Newton. Direction is A to B. Direction is V. This is first example. Then put a we can represent a vector something like this. This is a simple letter and this kind of curve. A, B, C, F. So this also a algebraic representation put in, but most of the cases this kind of representation is used with line segment because then we can represent the direction as well as the magnitude of such vectors. So this is a something like combined relationship, with combined representation, but we can use this kind of English letters to represent vectors in algebraic formation. Okay. Then also we can use this kind of formations put in. ඒ කියන්නේ ඉතින් මේ වගේම තමයි. මේ වගේ. හරි. Then write this one. Then write this one. After write this paragraph, then you can write this examples put in. Vectors and vector quantities. Vectors and vector quantities. Vectors and vector quantities can be represented. Algebraically by following symbols. Fourth one. The third one is third one. Fourth one is we can use some ball simple letters. Ball simple letters in printing booth. In printing, we can use ball letters. Ball letters without writing any curl line or something. We can use just letters. We can use just letters, but ball letters. Ball letters. Normally we use this one in printing, because it is easy to print out. So because if we use this kind of symbol, it will consume relatively longer time to type. But if you use ball letters, then it will be easy to type. Therefore, ball letters will be used normally in printing. Hello. Then the next topic, magnitude of a vector. Magnitude of a vector. Magnitude of a vector. Next topic is magnitude of a vector. Within the brackets, we call magnitude as the modulus. Magnitude of a vector within brackets, write it as modulus of a vector. Modulus of a vector. Okay. Suppose if you are given this kind of vector A, B, the magnitude of a vector means magnitude of modulus of vector can be represented this kind of symbol, this kind of symbol. It can be represented using this kind of symbol. That means if we consider about AB vector, the magnitude of AB vector can be represented by this. Here AB vector, you have to write these two lines put in both sides of the vector representation. AB vector. So this symbol is called the modulus of AB vector. The modulus of AB vector. Modulus or magnitude AB vector. You know AB vector, magnitude of AB vector is 10 Newton. Therefore, modulus of AB vector is equal 10 Newton. So this is the symbol of modulus. This is the symbol of modulus. Okay, modulus means magnitude. Did you get my point? If you got that term, please raise the hand. Okay. Then write down. Write down. The magnitude of a vector, the magnitude of a vector can be represented by this one. The magnitude of a vector can be represented by this one symbol. Can be represented by this symbol. Okay. Then draw this one and write this one. Draw this one and write this one. Okay. Then write the next topic. Some special vectors. Some special vectors. Some special vectors. Some special vectors. Okay. Some special vectors. Number one, null vector. Okay, null vector. Symbol is this one. This is symbol. Null vector. Okay, if I have a sense, tell me what would be a null vector. Null vector. Yeah, empty means it is the zero vector. Zero vector means whose magnitude is zero. The null vector, the magnitude of the null vector is zero. Therefore, null vector means a vector whose magnitude is equal to zero. Where is this one? Null vector. Null vector. Then another topic. Null vector is a vector. Null vector is the vector whose magnitude is equal 0. By this one. Okay. Then the second special vector is unique vector. Unique vector. Okay. Now tell me what would be a unit vector? Unit vector apa ini pula more? Tell me. Wait, dia kata we have read this one. Magnitude of a null vector is equal to 0. Now tell me what would be a unit vector? Similarly, what would be a unit vector? Yes. Unit vector means unit vector is a vector whose magnitude is equal to unit 1 to the unit 1. Whose magnitude is equal unit 1. So this is the symbol of unit vector U vector whose magnitude is equal 1 unit. 1 unit. Okay. Mela unit vector. They write this one. Unit vector is the vector whose magnitude is equal 1. Whose magnitude is equal 1. Okay, the third one is negative vector, or sometimes we call it as reverse vector, reverse. Negative vector. So negative vector means it is something like this. Please listen to me very carefully. Okay, suppose you are given this kind of vector. So this is your vector. Now you are given this kind of vector. Therefore, negative vector of AB or A vector is negative vector means it is the vector which is equal to the magnitude of this one, and the direction is exactly opposite to the given vector. That means the direction is exactly opposite to the given vector. So this is the negative A. Negative A. Therefore, if we consider about AB and BC line segment, if you consider about AB and CD, sorry, AB and CD line segment, they are parallel to each other. AB and CD are parallel to each other, as well as their length should be equal. Their length should be equal. But the only difference is the exact direction, or the arrowhead is in opposite way to the given vector. Therefore, negative vector means whose magnitude is equal to the given vector, but direction is exactly opposite to the given vector. And okay. They write the topic negative vector and draw this one. Okay, write this one. Write this under this figure. Negative vector. The negative vector. The negative vector. The negative vector is the vector whose magnitude is equal to the given vector. Is equal to given vector. but but the direction but the direction is exactly opposite to the given vector. Now you know about some basic idea about vectors protein. Now we are going to determine how to equate two vectors. That means how can we say whether the given two vectors are equal or not? How to say that part? Okay. Now we are going to identify two equal vectors. Two equal vectors. They write the topic. Next topic. Next topic. Okay. Equality of two vectors. Equality of two vectors. You know, a vector has a magnitude and a direction. Vector has a magnitude and a direction. Therefore, if any two vectors are equal, definitely there should be two mandatory things to be fulfilled. What are those? What are those? If any two given two vectors are equal, then definitely there should be two mandatory things to be fulfilled. What are those? What are those?
Magnitude and the direction.
Yes, but actually vectors have both magnitude and direction. But therefore, if any two vectors are equal, that means their magnitude should be equal separately and direction should be equal. Direction should be equal. Magnitude should be equal. Direction should be equal. Have it. Then look at this one. A B C. And suppose AB parallel to CD and AB is equal CD in it. That means they are parallel to each other and they are equal in magnitude. Magnitude. You know, direction also equal. Then this one is represented 10 Newton. This one is represented 10 meters displacement. This is a force. This is a displacement. And you know, now these two are vectors. Now these two are vectors. And now it is very clear both the magnitude and the direction of both vectors are equal. And both magnitude and direction of both vectors. Both magnitude and direction of both vectors are equal. Are they equal vectors? Are they equal vectors?
No.
No. Why? Why?
Units are different.
Hmm?
Different units. Magnitude different magnitude.
They are different physical quantities. They are different physical quantities, Pute. No, you cannot equal 1 kilogram of sugar with 1 kilogram of flour. No, Pute. Therefore, although the magnitude and directions are equal, they are two different physical quantities. Therefore, to equal, to equate two vectors, definitely there should be three mandatory requirements to be fulfilled. One is magnitude, that is obvious. Other one is direction, that was obvious. Third one is homogeneity. That means both vector quantities should represent the same physical quantity. Should represent the same physical quantity. Otherwise, we cannot say they are equal. Did you get my point? If you get my point, please press there. Where are this one? Where I done this? There are three mandatory requirements. There are three mandatory requirements to be fulfilled, to be fulfilled. To be fulfilled. To equate two vectors. To equate two vectors. Number one, magnitude. Their magnitude should be equal. Their magnitudes should be equal. Number two, their exact directions should be equal. Third one, both vectors should represent the same physical quantity. Both vectors should represent the same physical quantity. Within the brackets, right? Homogeneity. We call it as homogeneity. both vectors should represent the same physical quantity. Then write this one. Draw this one. This is a force to plane. This is a displacement. Draw this figure and write this. Have it. Now take the tuple. Take the vector tube. Vector tube. This one. Okay, then the first question. The first question. Equality of two vectors or negative vectors or finding the magnitude of given vector. Okay. Alright. Now we can determine equal vectors and negative vectors of given figures. Okay. Then look into the first figure. First one. ABCD is a parallelogram. There are 8 vectors in directions of AB, CD, DC, AD, AO, CO, OD, and OB. List the equal vectors and reverse vectors of the following figure. Suppose all the vectors represent the same physical quantity. Okay. Then do this one very quickly. Let's do the first question. Let's do the first question. Now here there is a parallelogram. This vector is A, B, S, P, Q, R, D, C. Now, among those vectors, what are the equal vectors and what are the negative vectors? Here you have to have your geometrical knowledge. One more thing. So when you are solving vector questions, with them, you have to have some geometrical knowledge, which will learn in all your especially special features of parallelogram. So you have to have very good understanding about the special features of squares, rectangles, and rhombus and normal parallelograms. So you have to have that knowledge. Therefore, please go through your all your books, and if you do not remember that thing, please do a quick recap. Because that knowledge is required, especially special features of rhombus, squares, then rectangles, parallels. Okay. Now tell me, what are the equal vectors? Equal vectors. Equal vectors. Equal vectors. those every vectors are represented same physical quantity. Therefore, you do not need to worry about the homogeneity. All are same physical quantity. Therefore, you just need to identify equal and sorry. You just need to determine the magnitude and the direction only. Now tell me, what are the equal vectors? What are the equal vectors? Please, what are the equal vectors?
Vector A and vector C.
Vector A and vector C, very good. Okay, vector A and vector C. What else? Vector, eh? That's it. That's all. Vector A and vector C. Then negative vectors. Negative vectors.
D and B. D and B.
Do you have to tell it as a pair of the negative
Yeah.
vector? Huh?
D and B. Vector D and
D
B.
and B, yes, D and B, very good. D and B. Then one more. Harusha. One more pair. Vinudha. Vinudha.
R and Q. R
Yeah.
and Q negative. R and Q and P and H, no?
Yes,
Negative.
Q and PNS. R and Q and PNS. As this is a parallelogram, this length and this length are equal. This length and this length are equal. Therefore, R and Q are in opposite direction. That means they are negative vectors. R and Q. Then P and S. Those are negative vector pairs. Negative vector. Did you get my point? Tena Susan?